Welcome back, everyone, to another installment. This is Unit 3, Section 3.1, Solving Systems of Linear Equations by Graphing Method. Example 1 says, determine whether the ordered pairs are solutions to the system. So I gave you a system, x plus y equal to -6, 3x minus y equal to -2. So we're going to test the point, -2, -4, and see if it's valid for the system. In order to be a valid solution, it needs to work for both equations. So I start out by first numbering my equations. 1 and 2. And in the first equation, we have x plus y equal to -6. We are substituting in -2 and -4. So -2 plus a -4, does that result in -6? -6 equals -6. It works for the first one. Now we need to check the second one. So you go into the second equation, we have 3x minus y equaling -2. Again, substitute in 3 times -2 minus a -4. Does that result in -2? So 3 and -2 make -6. Negative makes it +4. -2 equals -2. It worked for both equations, so your answer for this is yes, it's a solution. So now we're going to try the next one. It says 0, -6, and we're going to start again. First equation, x plus y equal to -6, and we're going to use 0 and -6. So 0 plus a -6, does that equal -6? -6 equals -6. It worked for the first one. Now to verify and validate if it works for the second one. So we have 3x minus y equals -2. 3 times 0 minus a -6, does that result in -2? Well, 3 times 0 is 0. Negative makes it +6. +6 does not equal -2, so that's a false statement. So then your answer for this would be no. Some things about solutions to systems. So we may have one unique solution. That's where they cross each other and they have one point of intersection. They are known as consistent and they're known as independent because each one is graphed independently of the other. A no solution system, you will see parallel lines. They will run side by side. They're known as inconsistent, they're independent, and they have the same slope. So they are independent because I see two separate graph lines. They have the same slope because they are running parallel to each other. Infinite solutions, you only see one line because it's a coinciding line. One graph line is sitting on top of the other. It's known as consistent, but these are known as dependent because you only physically see one line. They are going to have the same slope and the same y-intercept. Infinite solution means any ordered point on that graph line will work for the system. So example 2 asks us to graph the system. So they gave you two equations. The first one says y equals -3x minus 5, and the second one is in standard form, x minus 2y equal to 4. So first thing we're going to start, I'm going to number them 1 and 2. So the first one, we know we have a y-intercept, which is the b value of -5. So it's an ordered point at 0, -5. And then the m value is -3, so I'm going to write -3 over 1, which means down 3 to the right 1. So we're going to start graphing the first line. So it's starting at 0, -5. 1, 2, 3, 4. So you plot your point at 0, -5 on the y-axis. And we're traveling down. The elevator is going down 3 flights, and then you're going to the first room on the right. So we went down 1, 2, 3, first room on the right. And we sketch our graph line. Put arrows on both ends to signify that it is a graphed line. Then we go to the second equation. Equation number 2 says x minus 2y equals 4. I'm going to use, because it's in standard form, your x and y intercept. So remember, x-intercept, y is equal to 0. So I'm going to cover my y, and I see x equals 4, so the 4, 0 is my ordered point. The y-intercept, x is equal to 0, so I'm going to cover my x, and we get the equation -2y equals 4, so y equals -2. 0, -2 is your ordered pair. So we're going to plot 4, 0 first. I plotted 4, 0 on the graph line. Then you're going to do your y-intercept, which is at 0, -2. And then you are going to graph the lines. Okay, so when we finished our intersection point, you notice it is not exactly a whole number, which means that our solution value point is going to be a fraction answer. And if they needed an algebraic solution, then that's where we would go algebraically. So for right now, we are just graphing it, and we notice that it's 1 point of intersection on this problem. When we look at example 3, it says graph the system. It says -x plus 3y equal to -6. It's in standard form for us. The second one says 6y equals 2x plus 6. It's almost at the y equals mx plus b format. So first thing, number them, 1 and 2. We're going to work with equation number 1 first. -x plus 3y equal to -6. Again, since it's in standard form, we're going to go with x and y intercepts. So our x-intercept, remember, y equals 0. So we end up with -x equaling -6. So x equals 6. 6, 0 is our ordered point. Our y-intercept, x is equal to 0. So we end up with 3y equal to -6. So y equals -2, 0, -2. Again, you start by plotting 6, 0, and 0, -2. So we have 6, 0. I'm going to go in increments of 2 here. 2, 4, 6. And then our other one is at 0, -2. So 0, -2 is here. Remember, I'm using a scale of 2 on this graph. We sketch our line. We go to the second equation. Equation number 2 says 6y equals 2x plus 6. Divide every piece by 6. So y equals 1/3 x plus 1, which means the b value is at 1, so 0, 1. The m value is 1/3, which means up 1 to the right, 3. So we start our graph at 0, 1. And our graph is telling us that we're going to go up 1 to the right 3. So that's 2. 3 is the halfway point between them. And we sketch our graph line. At this point, we notice we have 2 parallel lines. So we have 2 parallel lines. Means there is no solution. Example 4 says graph the system. So we have x plus 4y equal to 8 and y equals -1/4 x plus 2. So the first one is in standard form. The second one is in slope-intercept form. So we're going to, again, number them 1 and 2. We're going to work with number 1 first. We have x plus 4y equaled 8. Remember, when it's in standard form, you're going to do x and y intercepts. So when it's x-intercept, y is equal to 0. So your equation becomes x equals 8, so you're at 8, 0. The y-intercept, x is equal to 0, so we become 4y equal to 8, so y equals 2, so 0, 2 for our ordered points. Again, we're going to go in increments of 2. The scale is 2. So 2, 4, 6, 0, 8, 0, 2. And you sketch your line. Second equation is in slope-intercept. So we have y equals -1/4 x plus 2, which means our b value is a 2. 0, 2 is where we start. Our m value is -1/4, which means we're going down 1 to the right 4. So we plotted our point at 0, 2, which happens to be the same y-intercept as the first graph. We went down 1 and we went to the right 4, so 2, 4. Notice that it also intersected the same graph line. So when I sketch my line, you have coinciding graph lines, one sitting on top of the other. So it's the same line, which means infinite solutions.